Hello, ladies and gentlemen. Today we're going to be talking about solving rational equations or equations where the exponents are fractions on the variable. So we've already talked about how to solve equations when there's a radical involved, and we also have learned how to convert between radical and exponential forms, or rational exponent form when we converted those fractional exponents to radicals. So today's lesson is going to be merging those two ideas together, solving with radicals and then converting rational exponents to radical form in order to solve. So that's how we're going to be learning how to solve these equations today. So again, remember all the things that go into solving or what it all entails or involves, getting the variable or the x alone, just remembering inverse operations like adding undoes subtracting, multiplying undoes dividing, squaring and square rooting undo each other, cube rooting each other undo each other. And the reciprocal fractions is another way that we can learn to solve today. And I'll go through the first example both ways and see which way you like solving. And then of course, check your work for extraneous solutions. Always, 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 always. Okay, example number one, we're going to be solving for x. So we have to get x alone. So we have to add 12 to both sides. We have 3x to the 2/5 is equal to 12. In order to get the 3 away from the x, we have to undo that multiplication, so we divide. So we get x to the 2/5 is equal to 12 divided by 3 is 4. So there's two ways you can think about solving these problems, and I'm going to go through both ways. So you can multiply, on an example like this, you can multiply the exponent by the reciprocal. So 5/2, because 2/5 times 5/2 gets you to an exponent of 1. But whatever you do to one side, you also have to do to the other side. And so technically our exponent on 4 is 1, so you're going to say 1 times 5/2. So that means that these ones would cancel, and you're left with x is equal to 4 to the 5/2. But in order to know what 4 to the 5/2 is, well, 1, you can plug it into your calculator, or 2, you can rewrite it in radical form. So remember, the denominator of that exponent becomes the root, and the 5 becomes my power. So the square root of 4 is 2, and 2 to the 5th is 32. Oh, sorry. Yes, sorry, 2 to the 5th is 32. So x is equal to 32. Or another way that you can think about it, so when you get to the step of x to the 2/5 is equal to 4, you can rewrite x as a radical, like we've done before. So x, the 5th root of x, all getting squared is equal to 4. But we don't just have a radical that we have to solve for, we have a radical and an exponent. So you can think about it this way, where you have to get rid of that squared power. So we're going to have to square root it on both sides. So then you have the 5th root of x is equal to the square root of 4 is 2. And then you're going to have to get rid of that 5th root by raising it to the 5 on both sides. So that's going to cancel, leaving you with x to the 2/5, which is 32. So you can think about it using the reciprocal exponent, or you can convert it to radical form and then solve it. I learned best when we did it in converting it to radical form. Plus, we've already learned in the last video how to convert it to radical form. So instead of trying to teach your brain something completely new, in this video, I'm going to continue to do the radical form one, okay? But there's also multiple ways to solve, and I just wanted you to be aware in case you have friends that have learned otherwise or differently. Okay, example number 2. So we have x plus 2 to the 3/4 minus 1 plus 7. Well, my first step is to get that parentheses all alone on one side, so I need to add 1 to both sides. So I have x plus 2 all getting raised to the 3/4 is equal to 7 plus 1 is 8. And I'm going to rewrite this guy as a fourth root of x plus 2, all getting raised to that third power equal to 8. Well, in order to do that, to undo that third power, we have to cube root it. So that's going to cancel this guy. And whatever we do to one side, we have to do to the other side. So I'm cubed rooting the 8 as well. So now all I'm left with on that left-hand side is the fourth root of x plus 2. And the cubed root of 8, that's like asking ourselves, you should be thinking in your head, what to the third power gets me to 8? And that would be 2. So the cubed root of 8 is 2. And now we have to undo that fourth root, so we have to raise both sides to the fourth power. So we can cancel that. So then we're left with x plus 2 is equal to 2 to the fourth is 16, minus 2, and x is equal to 16 minus 2 is 14. And I forgot to do this on the last problem, but that's okay because it's not an extraneous solution. But we should really check for extraneous solutions. So I'm going to do this in blue to check for extraneous solutions. So if I plug back in 14 plus 2, all getting raised to the 3/4, and I'll section this off so you know that I'm checking for extraneous solutions. So 14 plus 2 is 16 raised to the 3/4 is equal, or minus 1 is equal to 7. You can add 1 to both sides. Sorry, I did that math in my head. 1 plus 7 is 8. Now if we rewrite 16 to the 3/4 as a radical, it'd be the fourth root of 16 all getting cubed. And the fourth root of 16 is 2 cubed. Is that the same thing as 8? Yes, 2 cubed is equal to 8. So luckily 14, x is equal to 14 is my solution. It's not extraneous. Alrighty, example number 3. Let's get that 3 to the other side so we can isolate that guy. So we have x plus 2 all getting raised to the 1/3 power is equal to 7 minus 3 is 4. So we can rewrite that as a radical. It'll be the third root of x plus 2 is equal to 4. In order to undo a third root, we'll have to raise both sides to the power of 3. So that can cancel. So we get x plus 2 is equal to, 4 to the 3 is 64. And then we can minus 2, x is equal to 62. And don't forget, you got to check for extraneous solutions. So we have 62 plus 2, all getting raised to the 1/3 power, plus 3, is that equal to 7? Well, 62 plus 2 is 64, and that's all getting cubed root, plus 3 is equal to 7. Well, the cubed root of 64 we know is 4 plus 3, and we know 4 plus 3 is equal to 7. So x is equal to 62. I want to thank you all for taking such good notes, and I'll see you soon. Because that's all we have today is those 3 problems.